Hey folks, welcome to week one of our online learning. I know this is a little bit of a transition for everybody, but I think all of us have done some video notes in the past, so I'm going to try and keep things similar to how we did everything in class, as much as possible at least, to make it a little bit easier on all of us. So this week we're going to start with surface area and volume. And a lot of this is things that you already know. It might just be putting all of the pieces together. So this will be our surface area and volume part 1. So we'll just be talking about our basic shapes, how we're finding surface area and volume, and then next week we will get into composite figures, which is taking two different objects and putting them together to make one, as well as comparing similar solids. So kind of like we had similarity when we did triangles and different polygons, we'll talk about similarity and how it relates to three-dimensional objects. Okay. But for surface area and volume, we're going to start with surface area because I always find that one to be the easiest. And so what I'm going to do is I'm going to give shape that we talk about. The formula sheet should be posted on Schoology, so you have that as a reference. Okay. But when you get down to it, the surface area is when we take the area of all parts of an object and add them together. Okay. So surface area is taking all of the parts and finding their areas and then just adding all of those areas together, which is why I always like to start with surface area, because probably 80 to 90% of the shapes you can find their surface area without knowing a formula. Now the formula is always nice to use because it'll save you some time. It's kind of like a little shortcut, but just using your background knowledge of area of different shapes, you can always utilize that to get to the final answer as well. So what I mean is, like, if we were looking at, let's see if we can get this figure. So if you're looking at this type of shape right here, okay, you see a triangle and then another triangle, right? And then we have these rectangles on the side, right? So if you were to take this and actually break it apart, it's two triangles, right, and three rectangles. We know how to find the area of all of these shapes on their own, and then we can add those up, right? So that's all surface area is, but I'm going to go through and I'm going to give you a formula for each one as we go through the different shapes. And when you look at your surface area formula sheet, you'll see things that say SA. SA means surface area. You'll also see things that say LA, that's lateral area. Okay, that's these on the sides. Right, so whenever we look at these different figures, right, if I can get this back together, right, your lateral area is going to be the area of all of these sides put together. So the different shapes that you're going to have to work with are a triangle, right, which, remember, the area of a triangle is 1/2 base times height. You will have rectangles, and those will also sometimes be squares, but just for the sake of this we'll go with rectangles. Remember, your area of that is length times width. You'll also have different polygons, like a hexagon or a pentagon. And the area of that is 1/2 PA. Okay, and we'll talk about what that means in a minute. And then the last kind of basic shape that we'll have is a circle, which remember our area of the circle is pi r squared. So for most of our shapes, you can use these formulas and add them all together to be able to get to your final answer. Right? So if you don't remember a big formula for surface area, right, you can always use these smaller pieces to get you to your final answer. But when we're talking about surface area, the first kind of three-dimensional object that we're going to talk about is a prism. Right, a prism has two polygon bases with rectangle sides. Right, so it's two polygon bases, right, and it has rectangle sides. So this shape that I was showing you a minute ago, right, this is a prism, right, because it has two bases, right, which are these triangles here, okay, and then rectangles as the three sides, right. So this is a prism. Okay. The most common one you've seen is probably a rectangular prism, right. It has a square here, a square here. Those are their bases, right, and then we have the rectangles going around the side. This is another prism. This would be called a pentagonal prism, right? It has a pentagon on each side, or sorry, each base, right? So two pentagons that are the same, those are the bases. Okay. And then 5 rectangles going around the side. And so you can have a prism with any polygon as your base. Right? Here's one with the hexagon. Right? So essentially, if you looked at it, alright, imagine that this was the floor, right? You have a polygon on the floor and standing up, right? And then you have rectangles going all the way around. Right? So you can have any polygon as the base, right? And then you're always get rectangle along the sides. Right? So let's start with probably the most common, right, is going to be our rectangular prism. Okay, and if you struggle with drawing 3D objects, don't worry about that. That's not the point of this. Okay, the easiest way to do it is to draw a rectangle. Then from the top, do 2 diagonal lines out. Connect them in the back, so now you have your front and top of the shape. We're going to bring this line down. We're not going to go all the way down. You can connect it. Okay, and then some people like to do the full view, so how you do that is anything that you wouldn't actually see is done with dotted lines. So when we're looking at this, we have our width, we have our length, and then our height. Okay. And our surface area, okay, is just going to be the area of all of these different sides. So if we're looking at it, let's say this is our width and this is our height. Okay, the area of this rectangle right here is going to be our width times our height. Okay? But this is going to be the same here and on the opposite side. So we're going to have 2 of them. So you would have 2 width times height. Now, here we have our length and our height. Okay? The area of this would be length times height. But if it's here, it's going to be the same on the opposite side. So again, we have 2 of those. So we have 2 length times height. And then the last one is going to be here, which is our width and our length. So we have width times length, and then that's on the top and the bottom. So we're going to have 2, right, width times length. And that's our surface area formula. Now, you can figure out the surface area without it, right, by just finding the area of all the shapes and adding them up. Okay, this is the kind of formal formula that we will use. Okay, so this is known as a rectangular prism. Okay. And we're going to come back to this, right, when we get to volume, so just kind of hang tight, leave that there. Okay. Next up, we'll do a triangular prism, okay, which, let's see, we can, I think the easiest way to do that is to do a triangle. Bring this line down. And the last thing is to do our dotted line in the back. Yeah. Now, once we get past the rectangular prisms, right, sometimes our formulas will look a bit weird. So this, what we're going to do here, applies to any other type of prism other than this. Right, so we can use it with our triangular prism. Okay, we can use it with our pentagonal and hexagonal. Right, it's going to be the same regardless. Okay. So our surface area here, right, is going to be the area of this triangle, right, and that's going to happen twice, and remember we call that shape the base. So how you'll see it on your formula is going to be 2 capital B, right, and B is area of the base. Okay. So the area of this triangle times 2, because we have on the top and the bottom, right, or if we're looking at this shape, right, it would be the area of this pentagon times 2, because we have the top and the bottom. Right. And so then we have our bases covered, so now we just need to do everything around the sign. Okay. Well, if we're looking at a triangular prism, right, the area of this rectangle is going to be our height, right, times our width, right, or length times width, however you want to call it. Right, so it's going to be this, our height, times our width will be this side. Well, this side will be our height, again, times this width. Okay, and then we'll have this height, again, times this width. Right, so the height is staying the same, right, and then we're just multiplying by these distances around the triangle. But remember, we call the distance around any object the perimeter. So the way that we show it in a formula, and the way that makes it a little bit easier, is we take the height of our object, which is this, right, that side of the prism that we were talking about, times P. Okay, and anytime you see the letter P, that's going to be perimeter of the base. Our surface area formula is going to be 2 times the area of the base plus our height times the perimeter of the base. And that goes for any other type of prism. Alright, so this works for triangles, pentagons, and hexagons. Alright, we'll use the same formula. Right. If it's a triangle, remember we have our area is 1/2 base times height. Okay. Now the thing that trips people up the most is that this height is talking about the height of the triangle, not the height of the whole object. For a pentagon and a hexagon, it's 1/2 P. Remember, P is the perimeter times A. A is something known as the apothem, which is a kind of weird word, but if you were looking at one of these shapes and you went from the center out to the edge, that would be apothem. It's kind of like the radius of that shape. Now, anytime you have that number will be given to you. So if we're looking at this half of it dotted. Might not be the best, but it gets the point across at least. Our surface area for this, right, we have the area of this circle, and that's going to happen twice. Remember, the area of a circle is pi r squared, and then we have two of them because we have the top and the bottom. This is our radius. Plus, right, the area of this thing going around the side. Well, remember we said that that is just a rectangle. Right, so if we're looking at this cylinder, right, let's say this is our height, okay, and when we roll it out, right, the area of this shape is just going to be our height, right, times our width. Well, the width of this, remember this goes around perfectly around the circle. So the width of this is actually the same as the distance around this circle, which remember is circumference. Okay? So that'll be height times 2 pi r. I also apologize if you can hear my dogs. They're going crazy today, so they might be barking a lot. Alright, so we have our prisms, we have our cylinder. Okay. Next we're going to do our pyramid. So our pyramid, we are going to have a polygon base with triangle signs. Right, so it's only going to be one polygon as the base. Right, now the most common way that we see a pyramid is like this. Right, it's kind of like the ones that you see in Egypt, where it has their 4 triangles, okay, and then this rectangle or square on the bottom. But you can also see one like this. Right, so it has 3 sides, which means it has a triangle base. And just like our prisms, right, we can have all sorts of polygon bases here. Okay. For the sake of this, we're going to draw one with a or a square base. So I think the easiest way to do this is kind of draw a slanted square or a rhombus. I guess it's the easiest way to say it, but make this half of it dotted, and then you're going to draw lines up to the same point at the top. So our surface area, well, when we're looking at this, it's just the area of all of our shapes together, our base. Right, so we're always going to have the area of our base. Remember, that's a capital B. Plus, right, the area of the sides. Well, this is a triangle. Remember, our triangle is 1/2, right? This base times the height. And then here we have 1/2 this base, right, times the height. 1/2 this base height, and then 1/2 this base height, right? So notice our base for all of these is going all the way around, so that's going to be our perimeter. So the way that we see it in our formula sheet is 1/2 LP, where L is the height of these triangles. We can't use h because h talks about the height of the entire object. Okay, remember, P is the area around this base. Okay. L is going to be the height of each triangle. Right, and so we do 1/2 L times P, and that'll give us the area of all of those triangles at the same time. Okay. Alright, and so that actually works with any type of pyramid regardless of what shape the base is. Now, something you'll have to watch out for is if you have a rectangle pyramid, then these heights right here might not be the same on each triangle. Alright, so you have to watch out for that, and you might have to do the triangles individually. Right. Next up, we have cone. Which cone is like a party hat or icing cone. We have a circle base. There will always be a circle, and then this piece around it. So I always think the easiest way is to draw like a little oval, and then to just bring the two little points down. And when we're looking at this, right, we have a radius because we're dealing with a circle. And then this distance here is again known as L, right? So kind of just like we saw up here. So our surface area formula is going to be the area of our circle, which is pi r squared, plus the area of this piece that wraps around it. Right? And this is one that we don't really have an easy way to figure that out without remembering the formula, so that is pi r L. And then the last one that we have is the sphere, which, remember, is anything like a ball or like a globe or anything like that. So the easiest way to draw that is draw a circle, a little curved line here, and then it's you're drawing two circles, right? But the second half of this circle is going to be dotted because that's like the back of our sphere. Okay? And this is essentially just made up of a bunch of circles, so we're still going to have a radius, which is the center of the sphere all the way out to the edge. Right? And our surface area is 4 pi r squared. Okay, so it's just going to be 4 pi r squared. We're not going to get into where that comes from because there's multiple different ways to but we know that you proofs. But if you would like to try and find out where that comes from. I'll give you a hint to do with a cylinder. Okay, that's just a bonus. You don't have to do it, but if you're one of if you're a person either interested in where all these come from, then you're always more than welcome to go check that. I think it's pretty cool. So it's all of our surface formulas. Now we're going to go back and add the volume. Okay, which remember, volume is just all the space that's being taken up inside. So we're going to go back to our rectangular prism, our volume. Okay, it's three-dimensional, so it's essentially saying we have this if I take this amount of space, this square or angle, right, and I was going to back it up, right, how many times would I be able to do that? Okay, how much can actually fit on this prism? Okay, so the way that you actually do is you take the area of your base, right, so that little square on the bottom, and we multiply it the height. Telling us how many times we can fit this. We can fit it amount of distance that we have in each. So look at prisms that look like it's the same thing, right? It's this base at the bottom times. Right. So we actually write it as capital B 8 or B of the base. So we're taking the area of this thing at the bottom, right, and multiplying it by the height. Now cylinder, we're actually doing the same thing. Right? We're going to take the area of the circle at the bottom and multiply it by the height, because that's how many times we could fit this amount of space, right? That's the distance we have to fill up. So it's the area of the base times the height. Now sometimes on your formula sheet, remember area of your base is the circle, which is pi r squared times your height. So sometimes you might see it like this, sometimes you'll see it like that. Right? But essentially, if you have two bases, so you have a shape on the top and the bottom, your volume is going to be the area of that base multiplied by however tall it is. Right. For your pyramid, right, your volume is going to be 1/3 area of the base times the height, right, where the height is the distance from the top down to the middle. Right, so when we're looking at this shape, it's like if we took a string and started from this top point and went right through the middle of the shape and ended right here at the middle and the bottom. Right, so it's just how tall it is. Okay, so it's going to be 1/3 area of the base, which remember the base is going to be any polygon down here, times height. Your volume for the cone is actually the same thing. Sorry, 1/3 area of the base times the height. Right, where your height is going to be this distance. And then lastly, our volume of the sphere is going to be 4/3 pi r cubed. So that is kind of everything you need to know about the basics of surface area and volume. It's really just kind of understanding the formulas and what to plug into which place. Right? None of it is extremely complicated, but it does take some time to get used to looking at different shapes and figuring out which piece, right, or which value goes in which part of the equation. Right, so for this week you have two practice options. You can either do IXLs, right, you're going to do 10 minutes on each of the IXLs listed in the instruction sheet, right, or there's a practice page posted on Schoology as well as an answer key, right, and you can work through that. Doesn't matter which one you pick, right, both options give you plenty of practice. Right, some people just prefer paper over the internet. Some of you like IXL, some of you don't, so it's all just a matter of what your preference is. If at any point you get stuck or you are having problems, please reach out through email. You can email me at mholmes@k12albemarle.org, or you can email Mr. Baker at bbaker2@k12albemarle.org. Right, you can also join either of our office hours. I have office hours Wednesday morning, right, and Mr. Baker has office hours Friday afternoon. So if either of those work better for you, then feel free to join either one.